All right, today we're going to talk about ellipses. Um, I'll let you read the definition of ellipse on your own, but here's kind of a visual that you can see. Those distances remain constant. If you add the two sides together, it's always going to be the same distance. So you can kind of explore a little bit here. Um, you can make it kind of a squished. Actually, I'm going to enlarge that a little so that I can make that elongated. Or if I make my B, I can make it tall and skinny. And if you might want to make a note here, if my A is smaller than my B, it's going to be kind of squished on the sides. If my A is bigger than my B, it's going to be squished on the top and the bottom. Okay? So the way I always remember it, if A is bigger, that's underneath my X. That means my X-axis. There's more happening along it. If my B is bigger, that's happening underneath my Y-axis. So what's happening, or happening underneath my Y-coordinate. So that means what's happening along there on my Y-axis is bigger. So then, here, we've got x minus h quantity squared over 9, y minus k quantity squared over 36 equals 1. And what's happening here is, if I move my h, that's like moving the x-coordinate of the center. Moving the k is moving the y-coordinate. It's kind of like our circles. And if you look at that equation, that is actually very similar to the equation of a circle. If I were to change that so that my A and B are the same, you might even notice that you end up with a circle. So, if you're taking notes, which I suggest you do, or you can use the desmos activity as your notes, you'll want to make sure that you have this down, or at least understand everything here. An equation of an ellipse has a center of 0, 0, can be written in this form of x squared over a squared plus y squared over b squared equals 1. If it doesn't have a center of 0, 0, it's just going to have an x minus h quantity squared in the numerator and a y minus k quantity squared in the other numerator. If you notice, an ellipse is always going to be equal to 1. And it's always going to be separated with a plus sign. So, in class, I'm going to ask you to do these on your own, but I'm going to go ahead and go through two of them right now. I'm going to do this one right here that is kind of skinny and kind of elongated. So the first thing I need to do is figure out my center. So my center, I'm going to guess, is right there. So negative 2, 4. And I'm going to go ahead and do my y right here. And I already see a mistake I made. And you guys might see that mistake too. I meant to put a plus sign right there. Well, you notice, yeah, I've got a circle. It's got the right center, but I need to stretch that out. So I'm going to have to make my A a lot bigger. So one thing that you can do is from that center, count over how far it goes, to the right or to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let's put 10, and then I need to square it. And I might have to make some adjustments at the end. Looks like instead of 2, that might have needed to be 3. And it looks like I'm going to get lucky with my y, because that would be just 1 squared. Because from the center, I'm going up 1, down 1. Let's go ahead and do this one right here. So again, I want to find my center. I'm thinking that it's 5, negative 2. I'm going to be kind of lazy on this one and just retype some things. So 5, negative 2. Let's just start with a with 1 right there. So now, looks like I've got the same center. Let's see how long it is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, half of that is 5, and 5 squared is 25. And that's going up and down, so that would be with my y-axis. So 5. If I put 25, that's fine, but I wouldn't want to put 25 squared. Now, I need to figure out how far over. So I'm going to look and see how many spaces I have. 1, 2, 3, 4, 5, 6. Half of 6 is 3, so I've got 3 squared. And look, it covered it up. What I'd suggest you do is try the other 2 on your own. It might take some trial and error, and that's okay. We talked a little about this already, about sometimes it looks like it's squished on the top and the bottom, and sometimes it's squished on the sides. And we're going to be talking more about that. But if it is squished on the top and the bottom, your major axis, which is going to be your longest axis, is going to be horizontal. If it looks like it's squished on the sides, your biggest axis is vertical. It's going to be up and down. This is called your major axis. And you're going to have points on the top and on the bottom. And those are called vertices. Your minor axis is your short axis. Here, my short axis is vertical, and here my short axis is horizontal. These are called co-vertices. How are the major axis related to the minor axis? Where do they intersect? Well, they intersect at the center of the ellipse. So on this one, and we talked about this a little bit, what must be true in this equation for the major axes to be horizontal? Well, horizontal will be this way. That's along my x-axis. That means what's underneath the x has to be bigger. So A must be larger than B. All right. So we actually have another piece of information that we need to talk about. And you can use those sliders right now. And what we're going to talk about is the focus. Circles don't really have a focus because the focus is just the center. So if we had a perfectly round circle, let's go ahead and make that a radius of 8 and 8. Yeah, see, it meets up right there in the center. But we don't really have that with an ellipse. We have what we call focus or foci. And they're always going to be along the major axis or your larger axis. And you can see how they change as you change your A and your B. There is a relationship between them. And right now is that relationship. You will want to make a note of this, probably have this written down someplace. It looks very similar to the Pythagorean theorem, but it's not, so be careful. The foci are always C units away from the center and are on the major axis. And if A is greater than B, C is the square root of A squared minus B squared. If A is less than B, C is the square root of B squared minus A squared. So here, looks like A is larger, A is 5, B is 4. So my C is going to be, let's see, how do I do square root? There you go. Just typed in SQRT, and that would be 5 squared minus 4 squared, which is going to be 3. Oh, look at that. It calculated it for me. I didn't realize it would do that. So it looks like my foci are 3. That means that along the major axis, it would be 3 units from the center. Okay? So let me say that again. The foci is 3 units from the center. So on here, we need to move them to where those foci are going to be. Well, I know my major axis is along here, but I need to actually do some math, so I need to figure out what A and B are. So I'm going to figure out what, and they've got my center, so I need to figure out what that is. It looks like I'm going from 0 up to 10, so it looks like I would have squared minus, and then 1, 2, looks like I'm going over from 2 to 1, 2, 3, 4, 5, 6. 6 squared. And that's going to give me, I want to keep in math type here, 100 minus 36 is 64, and that is going to be 8. So from my center, I'm going to go up 8 units, because that's along my major axes, and then I'm also going to go down 8 units, because that's also along my major axes. Okay? The foci are always going to be along your major axes. All right, we are going to be going over this a little bit more, but this should be enough to get you started. Enjoy.